If you stepped outside tomorrow morning and noticed something impossibly wrong, the sun hanging motionless in the sky, the wind dying to an eerie stillness, time itself seeming frozen, you would be witnessing the most catastrophic moment in Earth's 4.5 billion year history. Our planet has suddenly, inexplicably, stopped spinning for all of human existence. Earth has been our cosmic dance partner, spinning faithfully once every 24 hours at over 1,000 miles per hour. At the equator, this rotation gives us day and night, drives our weather patterns, and shapes the very flow of our oceans and atmosphere. Recent NASA research shows that climate change is actually affecting Earth's rotation, with melting ice causing the planet to slow by mere milliseconds. But what we're about to explore tonight is far more dramatic in this journey through one of the most profound thought experiments in planetary science. We'll discover what happens when the fundamental force that has shaped our world since its birth comes to an absolute stop. Scientists assure us this scenario is extremely unlikely to ever occur naturally, but the physics of imagining it reveals extraordinary truths about our dynamic, living planet. So settle in, let your mind wander to this strange new world, and let's explore together what would unfold in the hours, days, and eons after Earth's final spin. Imagine the exact moment when 1,000 miles per hour becomes zero. Picture yourself standing in your backyard on what seems like an ordinary morning. The coffee cup in your hand steams gently in the cool air. Birds chirp in nearby trees. The world feels perfectly normal, perfectly safe. Then, in an instant that defies every law of gradual change in nature, our planet's 4.5 billion year dance comes to an abrupt halt. The physics of this moment would be unlike anything our universe has ever witnessed. Earth, this massive sphere weighing approximately 6 times kilograms, has been spinning with the momentum of incomprehensible force. Scientists calculate that our planet's rotational energy equals roughly 7.07 times 1033 joules, enough power to supply all of humanity's energy needs for millions of years. All of that energy, in our thought experiment, vanishes in a heartbeat. But here's what makes this scenario so fascinating to contemplate. While Earth suddenly stops, everything else continues moving at the speed the planet was spinning just moments before. Let your mind drift to that coffee cup in your hand. At the equator, you and everything around you were traveling eastward at about 1,040 miles per hour, faster than the speed of sound. When the ground beneath you stops, but you don't, the laws of physics take over with gentle yet inexorable certainty. You would continue moving eastward at supersonic speed, along with every car, every building, every tree, every grain of sand not firmly anchored to the bedrock itself. This is Newton's first law in its most dramatic demonstration. Objects in motion tend to stay in motion unless acted upon by an outside force. The outside force stopping Earth doesn't immediately stop everything on Earth's surface. If you were standing at the North or South Pole during this moment, your experience would be remarkably different. The poles, being the axis points of rotation, weren't moving horizontally at all. You might feel a strange wobble, a moment of disorientation, but you wouldn't be flung across the landscape. You might even have a few precious seconds to notice the sudden, unnatural stillness in the air before the greater chaos begins. But for most of us, living in the middle latitudes, the experience would be swift and overwhelming. At New York's latitude, the eastward speed is about 800 miles per hour. At London's position, around 650 miles per hour. These aren't just numbers. They represent the hidden velocity we've been traveling our entire lives, masked by Earth's faithful rotation. In this moment of cosmic stillness, the atmosphere itself becomes a character in our story. The air around our suddenly motionless planet doesn't stop either. Imagine winds of unprecedented force, not the gentle breezes we know, but atmospheric rivers moving at hundreds of miles per hour, carrying with them everything not anchored to the ground. These wouldn't be the rotating storms we're familiar with, but straight-line winds of a magnitude that would make the strongest hurricane seem like a whisper. The oceans, those vast bodies of water that have been spinning with Earth since they first formed, would also continue their eastward journey. Picture the Atlantic, Pacific, and Indian Oceans as enormous waves, each one carrying the momentum of billions of tons of water, moving faster than any tsunami in recorded history. These waters would crash against the western shores of every continent with indescribable force, reshaping coastlines in minutes that geology typically takes millennia to transform. As you imagine this moment, notice how quiet it would be in the instant before the winds begin, for perhaps a heartbeat or two, before the atmosphere realizes Earth has stopped. There would be an uncanny stillness, no breeze, no rustle of leaves, even the familiar background hum of our rotating world, a sound so constant we never consciously hear it, would vanish. This silence would be broken not by sound, but by movement. The trees, no longer held in place by their roots alone, would lean eastward like wheat bending in a field. Buildings would creak as their foundations suddenly experienced stresses they were never designed to handle. The very ground would ripple as the surface layers of soil and rock, not perfectly attached to the deeper bedrock, begin their own eastward slide. Scientists studying planetary rotation have helped us understand that Earth's spin isn't perfectly uniform even under normal circumstances. Our planet wobbles slightly, speeds up and slows down by tiny fractions as ice melts. As the atmosphere changes, as ocean currents shift, these variations are measured in milliseconds. Changes so small that atomic clocks are needed to detect them. But in our imagined scenario, we're contemplating a change of infinite magnitude, from rotation to complete stillness in an instant. The energy that would be released in such an event staggers the imagination. That rotational energy we calculated, 7.07 times kd joules, has to go somewhere. In the real world, energy is never truly destroyed, only transformed. In our thought experiment, this energy would become heat, kinetic energy of flying objects, and massive geological upheaval. The surface of Earth would become a furnace, heated not by the sun, but by the friction of everything sliding across everything else at supersonic speeds. Yet, as we explore this impossibility, we begin to appreciate something profound about our actual world. Right now, as you listen to these words, you're traveling through space at incredible velocity. And yet you feel perfectly still. You're moving around Earth's axis. Earth is orbiting the Sun at 67,000 miles per hour. Our solar system is rushing through the galaxy, and our galaxy itself is speeding through the cosmos. All of this motion is so perfectly synchronized that we experience it as perfect peace. The moment of Earth's stopping would also mark the beginning of a new relationship with time itself. Our entire concept of day and night, built around a 24-hour cycle, would become meaningless. Clocks would still tick, marking human-invented hours and minutes. But these measurements would no longer correspond to any natural rhythm. The sun would freeze in the sky, creating the first eternal moment in Earth's history. Half the planet bathed in perpetual daylight, the other half beginning an endless night. In this strange new world, East and West would take on entirely different meanings. East would become the direction of destruction, where everything that could move would pile up. West would become the direction of stillness, where the land itself might remain relatively undisturbed. North and south would still point toward the poles, but without rotation to define them through magnetic fields and atmospheric circulation. Even these ancient directions would begin to lose their familiar significance as we contemplate this moment of stillness. We're really contemplating the hidden forces that shape every second of our existence. The gentle pull you feel when a car takes a turn, the way water spirals down a drain, the very fact that you can stand upright on a sphere hurtling through space. All of these everyday miracles depend on Earth's faithful spin. But our imagined world is just beginning its transformation. The moment of stopping, dramatic as it would be, is merely the first note in a symphony of change that would reshape every aspect of our planet. The immediate chaos would give way to new patterns, new systems, new forms of order that Earth has never known. As the dust settles, quite literally, from this first catastrophic moment, our still world would begin to reveal its secrets. The waters would find new resting places, the atmosphere would discover new currents, and the very shape of our planet would start a slow transformation that would unfold across geological time. But that's only the beginning. The real change would come as these waters begin their strangest journey, flowing toward destinations that would create a world map unlike any we've ever imagined. As we prepare to follow these wandering oceans, let your mind rest in this moment of impossible stillness, where the only certainty is that everything we know about our world is about to change. As the spinning stops, our oceans begin their strangest journey. In the aftermath of that first moment of chaos, as the winds begin to calm and the debris settles, something extraordinary starts to happen beneath the waves. For billions of years, Earth's rotation has been sculpting the shape of our oceans through an invisible force. The centrifugal effect that pushes water outward toward the equator, creating a subtle but significant bulge around our planets. Without rotation, this ancient force simply disappears. Imagine standing on a beach in what was once Brazil, watching the Atlantic Ocean begin its slow retreat. The water doesn't rush away dramatically. Instead, it begins a patient, inexorable journey toward the poles, following gravity's purest call. The ocean level drops gradually, maybe a few inches each day, revealing sandbars that have been hidden. for millions of years, exposing coral reefs that have never felt sunlight, unveiling underwater mountain ranges that cartographers never knew existed. This is perhaps the most profound reshaping our planet would undergo. Research by cartographer Witold Fracek has shown us exactly what this new world would look like. Using sophisticated modeling of Earth's gravitational field without rotational forces, scientists have mapped the stunning transformation that would unfold across our ocean basins. The Mediterranean Sea, that ancient cradle of civilization, would begin to shrink dramatically. Picture the French Riviera expanding outward as water levels drop by hundreds of feet. The Italian peninsula would grow wider as underwater plains emerge between Sicily and the mainland. Greece would find itself with thousands of new islands, as submerged peaks break the surface for the first time in geological history. But it's in the far north and south that the most dramatic changes would occur, as trillions of gallons of seawater migrate toward the poles. Something unprecedented in Earth's history would begin to emerge, to vast polar oceans, deeper than any current sea, surrounding the Arctic and Antarctic regions. In the north, this new ocean would swallow much of what we know as land. Picture the northern reaches of Canada, Alaska, Greenland, Scandinavia, and Russia slowly disappearing beneath rising waters. The ancient ice sheets of Greenland, already melted by the atmospheric chaos of our stopped world, would be replaced by a deep polar sea. Cities like Anchorage, Reykjavik, Helsinki, and vast swaths of Siberia would become the new Atlantis, remembered only in the geography of a world that once spun. As you imagine this transformation, let your mind drift to the equatorial regions, where an entirely different story unfolds. The great ocean basins, the Atlantic, Pacific, and Indian Oceans, begin to reveal their hidden topography. The Mid-Atlantic Ridge, that underwater mountain range that marks where continents drift apart, would emerge as a new land bridge connecting Europe and North America. You could, in theory, walk from Portugal to Newfoundland across terrain that has been underwater since the continents first separated. The Pacific Ocean, Earth's largest and deepest body of water, would undergo the most spectacular change of all, as water levels drop by potentially thousands of feet near the equator. Underwater seamounts would become island chains. The Mariana Trench, deepest point on our planet, might finally see sunlight filtering down through much shallower waters. New continents would emerge from the Pacific's depths, land masses larger than Australia, connected by ridges and valleys that have been hidden beneath miles of water. For hundreds of millions of years, this great redistribution wouldn't happen. Overnight, ocean currents, no longer driven by the Coriolis effect of Earth's rotation, would need to establish entirely new patterns. The Gulf Stream, that great river of warm water that keeps Europe's climate temperate, would simply cease to exist. In its place, new currents would form, driven purely by temperature differences and the geography of our transformed ocean basins. Picture the Caribbean Sea, that tropical paradise, slowly draining as its waters join the great migration toward the poles. Islands like Jamaica and Puerto Rico would find themselves connected to each other and to the mainland by bridges of exposed seafloor. The Amazon River, no longer reaching a sea at its mouth, would flow into lakes and marshlands created by the new lower ocean levels. In the Indian Ocean, Madagascar would no longer be an island but a peninsula connected to the African mainland by a land bridge that emerges as sea levels drop. The Indonesian archipelago, those thousands of tropical islands, would become a single massive continent as the shallow seas between them drain away. The atmospheric pressure changes that accompany this redistribution would create weather patterns unlike anything in Earth's history, with massive bodies of water now located at the poles instead of spread evenly around the planet. Temperature gradients would become extreme. The polar oceans would begin to freeze in their eternal darkness, creating ice sheets of unprecedented thickness, not the relatively thin ice we know today, but glacial formations potentially miles deep. As these changes unfold across months and years, plant and animal life would face migration challenges beyond anything evolution has ever encountered. Marine ecosystems, adapted to specific depths and temperatures, would find their environments vanishing or dramatically altered. Deep-sea creatures, suddenly exposed to much shallower waters, would need to adapt quickly or perish. Coastal forests, now miles inland from any shore, would transform into landlocked ecosystems. The newly exposed ocean floors would become biological laboratories. Sediments that have been accumulating for millions of years would be revealed, creating vast plains of marine mud rich with fossils and nutrients. These areas might become the first places where life begins to adapt to our non-rotating world, as hardy organisms colonize the newly exposed terrain. Human civilization would need to completely reimagine itself around this new geography. Port cities that once commanded great trading routes would find themselves landlocked. New coastlines would emerge in places that were once the deep ocean floor. The very concept of maritime trade would need to be rebuilt around polar seas and the radically different ocean basins of the equatorial regions. Yet perhaps most remarkably, this redistribution would create a single, vast supercontinent around the equator, a ring of land connecting what were once separate continents. Africa and South America, Europe and North America, Asia and Australia, all would become connected by land bridges emerging from the drained ocean floors. As you picture this strange new world map, consider the profound beauty in these changes. Earth, no longer able to maintain its rotating equilibrium, would be finding a new balance, one based purely on gravity's pull toward the center, creating perfect spherical symmetry that our planet has never known. But this new geography is only the beginning of our transformation, as the waters find their new resting places at the poles. Something even more dramatic begins in the sky above, a division of our world into realms of eternal day and endless night that would challenge every form of life to adapt or perish. Half the world basks in eternal sunshine, while the other half enters permanent darkness, as our transformed oceans settle into their new polar homes. Earth faces a division more profound than any in its history. For the first time since our planet formed, the sun becomes a fixed star in the sky, motionless, unchanging, casting its light on one hemisphere while leaving the other in perpetual shadow. Picture yourself standing in what was once Western Europe, in the bright half of our still world, the sun hangs suspended at the same angle it held the moment Earth stopped spinning. If it was morning when the rotation ceased, it remains morning forever. If it was noon, high noon stretches into eternity. The shadows cast by mountains, buildings, and trees become permanent features of the landscape, as fixed and enduring as the rocks themselves. Without the gentle rhythm of day and night, without the cooling reprieve that darkness once provided, this sunlit hemisphere begins to transform into something our planet has never known. A realm of endless summer that grows hotter with each passing day. The physics of this warming are elegantly simple yet terrifyingly powerful every moment. That sunlight strikes the ground, water, and atmosphere, energy accumulates. In our spinning world, night provided a crucial balance, a time for surfaces to radiate their collected heat back into space, for temperatures to moderate, for life to rest and recover. Now, that cooling never comes. Imagine watching a thermometer. In this eternal day, as weeks pass, the temperature climbs steadily, relentlessly. What began as a pleasant spring morning temperature of perhaps 60 degrees Fahrenheit begins its inexorable rise. Week by week, month by month, the mercury creeps upward 70, 80, 90 degrees. Rivers that once flowed cool and clear begin to steam in the endless sunlight. By the end of the first year in this fixed sun, temperatures in many regions would soar past 100 degrees Fahrenheit and continue climbing. Lakes that have existed for thousands of years begin to shrink as their surfaces boil away into the superheated air. The Amazon rainforest, if it survived the initial chaos, would become a vast desert as its precious moisture evaporates under the relentless heat. But it's not just the heat that transforms this sunlit world. It's the unending nature of it. Plants evolved over billions of years to follow circadian rhythms, to open and close their leaves with the cycle of day and night, struggle to adapt to perpetual photosynthesis. Some might thrive initially, gorging themselves on endless sunlight, but most would eventually exhaust themselves, burning through their stored energy with no nighttime rest for recovery. Animals in this realm of eternal day would face challenges that evolution never prepared them for. Sleep cycles, migration patterns, hunting and feeding behaviors, all are deeply tied to the rhythm of day and night. Nocturnal creatures would either need to adapt to constant light or slowly disappear. Diurnal animals might initially seem advantaged, but even they depend on the cool reprieve of darkness for rest and temperature regulation. As your mind wanders to this bright, hot world, let it drift slowly to the other side of our planet, the shadow realm, where an entirely different transformation unfolds. Here, where the sun vanished the moment Earth stopped spinning, begins the longest night in planetary history. If you were standing in Eastern Asia when the rotation ceased, watching the sun disappear behind the horizon in what you thought was a normal sunset, you would have witnessed the last sunset that hemisphere would ever see dot in this world of endless darkness. Temperatures begin their own dramatic journey, but in the opposite direction. Without the sun's warming rays, the heat accumulated in rocks, soil, and water during the last day of rotation begins to radiate away into the cold vacuum of space. There's no sunrise to replenish it, No dawn to break the cooling cycle. Picture standing in this darkened world a year after the stopping. The temperature has dropped far below any winter you've ever experienced. In many regions, the cold would rival the polar conditions of Antarctica, but without even the brief summer respite that Antarctic regions sometimes enjoy. Rivers and lakes freeze solid, their surfaces becoming ice highways in a world where liquid water becomes increasingly precious. The night sky in this dark hemisphere would become more spectacular than any human has ever witnessed. Without city lights, for most artificial illumination would have failed in the chaos following Earth's stopping, and with the exceptionally clear, cold air, the stars would blaze with unprecedented brilliance. The Milky Way would stretch across the sky like a luminous river, and nearby planets would shine like beacons in the eternal night. Yet this dark world wouldn't be uniformly frozen. Deep underground, Earth's core continues to radiate heat regardless of what happens on the surface. Geothermal areas, places where underground heat reaches the surface, would become oases of warmth in this frozen realm. Hot springs that once provided pleasant relaxation would become literally life-saving sources of heat. And liquid water. Volcanic regions, too, would maintain pockets of warmth. The thermal features of places like Yellowstone or Iceland's geysers would continue functioning, creating steaming refuges in an otherwise ice-locked world. These areas might become the only places in the dark hemisphere where surface life could survive, clustering around these geological gifts like campfires in an endless winter night. But perhaps the most fascinating region of our transformed world would be neither the blazing day side nor the frozen night side. It would be the narrow band between them, the twilight zone, where eternal sunset meets eternal sunrise. Imagine this boundary region, this ring around our planet where the sun sits forever on the horizon. Here, in perpetual dawn or dusklight, temperatures might remain moderate enough for life to not just survive, but potentially flourish. This zone would experience neither the scorching heat of the day side nor the bitter cold of the night side. Instead, it would bask in the gentle, golden light of eternal twilight. This twilight realm would be where life makes its last stand on our transformed planet. Plants adapted to low light might thrive in this eternal golden hour. Animals from both the day and night sides might migrate here, creating unprecedented ecosystems as desert species fleeing the heat. Meet Ice Age survivors escaping the cold. Rivers flowing from the melting ice of the dark side would meet streams running from the boiling day side, creating unique thermal gradients within this zone. Hot springs from deep underground would mix with snowmelt from the twilight's cooler reaches, creating temperature variations that could support diverse forms of life in remarkably small areas. The atmospheric dynamics in this twilight zone would be unlike anything Earth has ever experienced. Massive temperature differences between the scorching day side and frozen night side would drive unprecedented weather systems through this narrow band. Imagine storms unlike any in Earth's history, not the rotating cyclones we know, but massive linear systems driven by the extreme temperature gradients between light and dark. Clouds would form and dissipate in patterns never seen before, perhaps creating their own unique climates within the twilight zone. Some areas might become perpetually foggy as hot air from the day's side meets cold air from the night side, creating thick mists that could provide their own microenvironments for adapted life forms. As you picture yourself walking through this strange twilight world, notice how the light never changes. The sun sits motionless on the horizon, casting long shadows that never move, painting the landscape in permanent hues of gold and amber. Time would lose much of its meaning here, measured not by the progression of light and shadow, but by the slower rhythms of weather, seasons that no longer exist, and the patient adaptation of life to circumstances that Earth has never faced. In this realm between fire and ice, the air itself begins to move in ways our planet has never known, creating wind patterns and atmospheric rivers that will reshape even our understanding of weather itself. When Earth stops spinning, the atmosphere remembers what the ground has forgotten. In the aftermath of our planet's great stillness, as temperatures begin their dramatic divergence between the scorching day side and the frozen night side, the atmosphere itself becomes a character in our transformed world's story. The air, which once moved in the familiar patterns of rotating weather systems, now faces the greatest reorganization in Earth's atmospheric history. Picture the atmosphere as a vast, invisible ocean that has been spinning with our planet for billions of years. When the solid Earth beneath suddenly stops, this aerial ocean continues its eastward journey, creating winds of a magnitude and persistence that our rotating world never knew. But this is only the beginning of the atmospheric transformation that would reshape our understanding of weather itself. Without Earth's rotation, one of the most fundamental forces shaping our weather patterns simply vanishes: the Coriolis effect. This invisible hand has been guiding the spiral of hurricanes, the curve of jet streams, and the circulation patterns of every weather system since our atmosphere first formed. In our still world, air masses would move in ways that seem almost alien compared to the rotating storms and curved wind patterns we've always known. Imagine watching the first weather systems form in this new world. Instead of the spiral hurricanes and rotating low-pressure systems we recognize, massive linear storms would develop, straight-line weather fronts, stretching across thousands of miles, driven by the simple physics of hot air rising and cold air sinking, undeflected by rotational forces. The most dramatic atmospheric change would emerge from the temperature extremes we explored in our twilight journey, with one hemisphere growing ever hotter and the other becoming perpetually frozen. The atmosphere would develop a circulation pattern unlike anything in Earth's meteorological history. This wouldn't be weather in any sense we understand. It would be a planetary scale engine of air movement, driven by temperature differences more extreme than any natural system our world has ever experienced. In the scorching day side, superheated air would rise in massive columns, creating updrafts of unprecedented power. Imagine standing in what was once the Sahara Desert, now even hotter under the fixed sun, watching pillars of heated air rise miles into the atmosphere with such force that they create their own localized low-pressure systems. These thermal columns would be visible from space, distorting the view like massive heat mirages rising from the surface of our transformed planet. This rising air would need somewhere to go, and the laws of atmospheric circulation would send it in the only direction possible, toward the frozen night side. Picture this: the hottest air from the brightest day side of Earth flowing like invisible rivers through the upper atmosphere, carrying heat and moisture on a journey to the darkest, coldest regions of our planet. But the real drama would unfold when this hot, moisture-laden air begins its descent into the night side. As it encounters the frigid conditions of the shadow world, it would create weather phenomena that meteorologists have never had to consider. Massive precipitation systems would form, not the rotating storm systems we know, but linear weather fronts hundreds of miles wide, carrying the last moisture from the dying day side and depositing it as snow and ice across the frozen night hemisphere. These wouldn't be gentle snowfalls. The temperature differentials involved would create precipitation of extraordinary intensity. Imagine blizzards that make Antarctic storms seem mild, driven not by seasonal temperature changes, but by the fundamental heat engine of a planet. Divided between fire and ice, the snow and ice accumulating in the night side would grow deeper, with each passing month, creating ice sheets that would make glacial periods in Earth's history seem modest by comparison. In the twilight zone, that narrow band where eternal day meets endless night, the atmospheric dynamics would be even more complex and fascinating. This region would become a battleground where the hot air masses from the day side meet the cold air masses from the night side, creating a permanent weather front that circles the globe. Picture standing in this twilight realm and feeling the constant breeze, not the changing winds of our rotating world, but a steady, persistent flow of air as the atmosphere continuously tries to balance the temperature extremes on either side. This wind would be warm on one side of you, carrying the heat from the day side, and cool on the other, bringing the chill from the night side. The humidity in this twilight zone would create almost magical atmospheric conditions. As hot, moisture-laden air from the scorching day side meets the cool air from the frozen night side, fog and mist would form continuously, not the temporary fogs we know, which burn off with the morning sun, but permanent atmospheric rivers of water vapor, creating landscapes shrouded in eternal mist. These mists would themselves become weather systems, moving in slow, stately processions. Around the twilight zone, some areas might develop their own unique climates. Temperate regions where the mist provides cooling and moisture, creating oases of habitability in our transformed world. Other areas might become permanently clouded, with precipitation falling continuously as the atmospheric moisture condenses in the cooler air. The wind patterns in this new world would also be remarkably steady compared to our familiar weather, without the rotation that creates the meandering jet streams and shifting pressure systems. The atmospheric circulation would settle into relatively predictable patterns. The hot air would rise in the day side, flow to the night side at high altitude, cool and descend, then return to the day side at ground level to complete the cycle. This creates what atmospheric scientists might call a Hadley cell of unprecedented scale, a circulation system that encompasses the entire planet. Instead of being confined to tropical regions as it is in our rotating world, The ground-level winds in this system would blow steadily from the night side toward the day side, carrying the cold air toward the regions where it would be heated and sent aloft again. Imagine the sound of these winds, not the changing whistle and roar of storms passing through, but a constant atmospheric presence, like the sound of a vast river of air flowing continuously round our planet. In some regions, this steady wind might create unique acoustic environments, producing constant low tones as air flows over mountain ranges or through valleys with unchanging consistency. The dust and particles carried by these global wind systems would also create atmospheric effects unknown in our rotating world. Without the complex circulation patterns that distribute particles in our current atmosphere, dust storms might develop that dwarf any weather phenomenon we've experienced. These wouldn't be temporary events, but persistent atmospheric conditions as these steady winds continuously transport material from one side of the planet to the other. Yet, perhaps most remarkably, this new atmospheric system would be attempting something our spinning world never needed to do. It would be working to equalize temperatures across the entire planet. The atmosphere would become Earth's circulatory system, continuously trying to carry heat from the scorching day side to warm the frozen night side. Even though the sun's energy would keep rebuilding the temperature extremes as these great atmospheric rivers establish their patterns, flowing invisibly but powerfully across our transformed world. They carry with them not just heat and cold, but the very breath of our planet's new existence. These winds would shape the final landscapes of our still Earth, carving new valleys, creating new deserts, and determining where the last refuges of life might flourish. But the atmosphere isn't the only system thrown into chaos by our planet's sudden stillness far above. Our technological companions that once orbited in perfect harmony with Earth's rotation now face their own crisis in the transformed sky above. In the space above our motionless world, satellites drift like lost stars. As we lift our gaze from the transformed landscapes and strange new winds of our still Earth, we encounter another realm of profound change, the space immediately surrounding our planet, where humanity's technological achievements suddenly find themselves in a universe operating by entirely different rules. For decades, we've populated the space around Earth with an intricate network of satellites, each one precisely positioned to work in harmony with our planet's rotation. Communications satellites, weather monitoring systems, GPS networks, scientific instruments, all carefully placed in orbits calculated to the millisecond, dancing in perfect synchronization with Earth's 24-hour spin. In our imagined world of stillness, this entire celestial infrastructure faces an existential crisis. Picture the International Space Station, that remarkable outpost of human presence in space, as it continues its orbital journey around our suddenly motionless planet. The astronauts aboard would witness something no human has ever seen. Earth hanging still beneath them while they continue their graceful arc through space. At 17,500 miles per hour. From their perspective, our planet would no longer appear to rotate slowly beneath them as it has since the station's first modules were launched. Instead, Earth would appear fixed in space, showing the same hemisphere continuously as the station traces its path around our transformed world. The most immediate casualty in this new sky would be our network of geostationary satellites. These technological marvels, positioned precisely 22,000 to 136 miles above the equator, have spent their entire operational lives maintaining perfect synchronization with Earth's rotation. They orbit at exactly the same speed that Earth spins, creating the illusion that they hover motionless in the sky, above specific points on our planet's surface in our world of stopped rotation. These satellites would suddenly appear to be racing across the sky at tremendous speed. Communication dishes that once pointed steadily at these fixed positions would lose contact as their targets streak eastward across the heavens. Television broadcasts, internet connections, international phone calls, all the invisible threads of communication that bind our global civilization together would be severed in the space of hours. Imagine the quiet chaos as control centers around the world lose contact with their satellites one by one. The gentle hum of global communication, which we take for granted every time we make a phone call or check the weather, would gradually fade to silence. Weather satellites that once provided continuous monitoring of storm systems would drift out of position, their carefully calibrated sensors now viewing entirely different regions of our transformed planet. The global positioning system, that invisible utility that guides everything from smartphone navigation to precision agriculture, would face perhaps the most dramatic disruption. GPS works by precisely measuring the time it takes radio signals to travel from multiple satellites to receivers on Earth's surface. The entire system depends on knowing exactly where each satellite is at any given moment. Calculations that assume Earth's steady rotation, with our planet suddenly still. GPS satellites would find themselves in orbits that no longer correspond to their programmed positions relative to Earth's surface. A GPS receiver that once confidently announced your location within a few feet would begin providing readings that drift further from reality with each passing hour. Navigation systems in cars, ships, and aircraft would gradually become unreliable, then useless, as the satellites they depend on slowly drift out of their expected positions. But it's not just the loss of services that would mark this transformation. It's the profound change in how space itself would appear from Earth's surface. For the first time in human history, the night sky would become truly stable. Without Earth's rotation, the stars would hang motionless in the heavens, no longer rising in the east and setting in the west in their ancient dance across the sky. In the hemisphere experiencing eternal night, this still sky would become more spectacular than any human has ever witnessed. With most artificial lighting systems having failed in the chaos following Earth's stopping, and with the exceptionally clear air of the frozen night, the stars would blaze with unprecedented brilliance. The Milky Way would stretch across the sky like a frozen river of light, and nearby planets would shine as steady beacons in positions they would maintain forever. Astronomers in this dark hemisphere would face both tragedy and unprecedented opportunity. Their great observatories would no longer need to track objects across the sky. Telescopes could be pointed at specific stars or galaxies and left in position indefinitely, long-exposure photographs that once required complex tracking systems. To compensate for Earth's rotation could now be taken with simple, fixed cameras. The universe would have become a still-life portrait instead of a moving panorama. Yet this astronomical gift would come at tremendous cost. The Northern Hemisphere's great observatories, places like the Very Large Telescope in Chile, the Keck Observatory in Hawaii, and the newly completed James Webb Space Telescope's ground support facilities, might find themselves on the scorching day side, where heat distortion and boiling atmosphere would make observation impossible. The satellites that do continue to function would provide entirely new perspectives on our transformed world. Earth observation satellites would capture the slow redistribution of our oceans, the formation of the great ice sheets on the night side, and the atmospheric rivers flowing between the hemispheres of fire and ice. These would be images unlike any in the history of space photography, pictures of a planet in the midst of the most profound transformation in its geological history. Communication satellites still in operation would need to be constantly repositioned, burning through their limited fuel supplies as ground controllers attempt to maintain contact with specific regions of Earth. Some satellites might be repurposed entirely, whether satellites becoming communication relays, scientific instruments, becoming emergency beacons for any surviving communities on the surface. The space debris that surrounds our planet, thousands of pieces of defunct satellites, spent rocket stages, and fragments from decades of space exploration would also begin to behave differently. Without Earth's rotation to help clear orbital paths through gravitational perturbations, some debris might remain in stable orbits for much longer periods. Other pieces might be affected by the changed atmospheric conditions, as the extreme temperature differences between day and night sides create new patterns of atmospheric expansion and contraction that influence orbital decay. Perhaps most poignantly, the handful of deep space missions that humanity has launched beyond Earth's orbit would continue their journeys into the cosmos, carrying with them radio beacons that call back toward a world that has fundamentally changed. The Voyager probes, Pioneer spacecraft, and New Horizons mission would continue transmitting data toward a planet they left spinning, unaware that Earth itself has entered an entirely new chapter of its existence. In this transformed sky, artificial aurora might become visible as solar-wind interactions with our changing magnetic field create new light displays. Without the familiar patterns created by Earth's rotation, these aurora would form in shapes and locations never before witnessed, painting the eternal night sky with curtains of green and blue light that move in slow, stately dances across the heavens. The International Space Station's crew, if they survived the initial chaos, would become humanity's most important observers of this transformation. Their continuous orbit would provide a unique perspective on the day-night boundary, the formation of the great atmospheric rivers, and the slow reshaping of our planet's surface. They would be the first humans to witness Earth's transformation from the perspective of space, documenting changes that ground-based observers could never fully comprehend. As our technological civilization adapts to this new sky, learning to function without the satellite networks that once bound our world together, deeper changes stir within the planet itself. far beneath the surface. In the molten heart of our world, ancient currents that have protected Earth for billions of years begin to respond to our planet's new stillness. Deep within Earth's core, ancient currents that have protected us for billions of years begin to fade. As we journey deeper into our transformed world, we must venture far beneath the changed landscapes, beyond the new ocean basins and strange wind patterns, into the very heart of our planet. Here, in the realm of liquid iron and unimaginable pressures, lies one of Earth's most fundamental systems, the magnetic field that has shielded all life from the harsh radiation of space. Since complex organisms first evolved, picture Earth's interior as a vast, dynamic engine that has been operating continuously for over 4 billion years. At the center lies our planet's solid iron core, about the size of the moon, surrounded by a churning ocean of liquid iron and nickel nearly 1,400 miles thick. This liquid outer core, heated by radioactive decay and the residual heat from Earth's formation, moves in complex patterns driven by convection currents, and, crucially, by the rotation of our planet itself. In our spinning world, this liquid metal ocean flows in intricate spirals and currents, guided by the Coriolis effect deep underground, just as our atmosphere and oceans are influenced by rotation above. These moving rivers of molten metal act like the coils in a vast electrical generator, creating the magnetic field that extends far into space around our planet, deflecting the deadly solar wind and cosmic radiation that would otherwise strip away our atmosphere and sterilize our surface. But in our imagined world of stillness, this ancient engine begins to stutter and slow. The relationship between Earth's rotation and its magnetic field is one of the most elegant examples of planetary physics. As our world spins, it drags the liquid outer core along with it, but not perfectly. The liquid metal lags slightly behind the solid mantle and crust above. This differential rotation creates shearing forces within the molten metal, stretching and twisting the iron-rich fluid into the complex flow patterns that generate our protective magnetic shield. Without rotation, these driving forces begin to weaken. The convection currents in the outer core, which once followed the twisted, spiraling paths created by our planet's spin, gradually simplify into more basic circulation patterns driven only by heat differences. Imagine watching these ancient currents slow and straighten, like a river that once rushed through rapids finding itself in a placid lake. This transformation wouldn't happen overnight. The magnetic field generated by Earth's core responds to changes over geological timescales, measured in thousands or tens of thousands of years. But the process, once begun, would be inexorable. Computer models of planetary magnetic fields suggest that without rotational forcing, Earth's magnetic field would gradually weaken and eventually collapse entirely, leaving our planet magnetically naked in space for the first time since the Archean Aeon. To understand what this means, we need only look to our planetary neighbor, Mars. Once, billions of years ago, Mars likely possessed both a substantial atmosphere and a protective magnetic field generated by a molten core. But as the red planet cooled and its core solidified, its magnetic field disappeared. Without this invisible shield, The solar wind, that constant stream of charged particles flowing from the sun, gradually stripped away Mars's atmosphere, transforming it from a world that might have harbored liquid water and life into the cold, thin-air desert we observe today. In our still Earth, the same process would begin to unfold, but on a planet still teeming with life. As the magnetic field weakens, more cosmic radiation and solar wind particles would penetrate deeper into our atmosphere, the aurora that now appear only near the poles. Those spectacular displays of green and blue light created when charged. Particles interact with our atmosphere along magnetic field lines, would begin to appear at lower and lower latitudes. Picture standing in what was once the twilight zone between eternal day and endless night, watching aurora dance directly overhead instead of being confined to the far northern and southern skies. These lights would be beautiful, but they would also be harbingers of our planet's growing vulnerability. Each aurora display would represent cosmic radiation penetrating deeper into our protective, atmospheric envelope. The weakening magnetic field would also begin to affect any remaining electronic systems on our transformed planet. Satellites still functioning in orbit would experience increased radiation exposure, causing more frequent malfunctions and shorter operational lifespans. Power grids on the surface, if any survived the initial chaos of Earth's stopping, would become increasingly susceptible to geomagnetic storms as our planet's magnetic defenses failed. But perhaps most significantly, the gradual loss of our magnetic field would begin a slow but steady erosion of Earth's atmosphere itself. This wouldn't be the dramatic atmospheric redistribution we explored earlier, but a more insidious process. The constant sandblasting of our upper atmosphere by solar wind particles, no longer deflected by magnetic forces, oxygen molecules, water vapor, and other atmospheric gases would slowly but continuously escape to space, carried away by the solar wind. The process would be so gradual that no human lifetime could perceive it directly, but across thousands of years, our atmosphere would begin to thin. The brilliant blue sky of the day side and the crystal-clear starscapes of the night side would slowly fade as the envelope of gases that creates these views gradually bleeds away into the vacuum of space. This atmospheric loss would create a feedback effect with the temperature extremes, already reshaping our world. As the atmosphere thins, its ability to transport heat from the day side to the night side would diminish further. The scorching temperatures of the eternal day would climb even higher, while the frozen night side would become even colder, accelerating the escape of atmospheric gases in a slow spiral toward the thin, cold conditions we observe on Mars today. Yet in the deep time of our thought experiment, even as the magnetic field weakens, other geological processes would continue. The liquid outer core, even without rotational forcing, would still be heated by radioactive decay and convection. It's possible that new, simpler patterns of flow might eventually establish themselves, perhaps generating a weaker but still protective magnetic field, just not the complex, dynamic field that our spinning world has maintained for billions of years. The solid inner core at Earth's very center would continue to grow slowly as the planet cools, just as it has throughout geological time. This process might even accelerate slightly. Without the complex stirring action of rotation-driven currents in the liquid outer core, the crystallization of iron at the inner core boundary would continue to release latent heat, helping to drive what convection remains in the liquid metal above. In the mantle above the core, that vast layer of hot rock that flows like thick honey across geological time, convection patterns would also begin to change. The great circulation cells that drive continental drift and volcanic activity have always been influenced by Earth's rotation through the Coriolis effect, even in solid rock flowing over millions of years. Without rotation, these patterns might simplify, potentially affecting the locations and intensity of volcanic activity across our transformed world. Some volcanic regions might become more active as mantle flow concentrates in new patterns, while others might quiet as the forces that once drove them change direction or weaken. The ring of fire around the Pacific Ocean, the volcanic zones of Iceland and the Mediterranean, the great rift valleys of Africa, all would slowly respond to the new patterns of heat flow in a non-rotating planet. These deep changes would unfold across timescales that dwarf human civilization. But they represent perhaps the most fundamental transformation of all. Our planet's magnetic field is older than complex life itself. It has been our constant, invisible guardian throughout the entire evolution of multicellular organisms. In our imagined world of stillness, Earth would gradually be returning to conditions more like those of its earliest youth, when the surface was bombarded by cosmic radiation and the atmosphere was thin and unprotected. Yet life, as we have learned throughout Earth's history, is remarkably resilient and adaptable. Even as the magnetic field weakens and the atmosphere slowly escapes to space, evolution would continue its patient work, perhaps finding new ways to cope with increased radiation, thinner air, and the extreme temperature gradients of our divided world. As our magnetic shield transforms and the very breath of our planet begins its slow escape to space, life on this strange new Earth faces challenges unlike any in its evolutionary history. In the narrow twilight zone between fire and ice, the final chapter of terrestrial evolution would begin to unfold. In the narrow band where eternal day meets endless night, life finds a way. As we emerge from the deep currents of our planet's magnetic heart, we return to the surface of our transformed world to witness perhaps the most remarkable story of all. The quiet persistence of life in conditions that Earth has never before experienced. In the twilight zone, that narrow ring circling our planet where the sun hangs forever on the horizon, evolution begins writing a new chapter in the 4 billion-year story of life on Earth. Picture this realm of eternal golden hour, where the light never changes and shadows never move. Here, neither scorching heat nor bitter cold dominates, but instead a perpetual state exists between the two extremes. The temperature hovers in ranges that, while challenging, remain within the bounds that life has learned to navigate. This narrow band, perhaps only a few hundred miles wide, becomes Earth's final sanctuary, a refuge where the great experiment of terrestrial biology continues under the strangest conditions our planet has ever known. The first migrants to this Twilight Realm would be the refugees from both sides of our divided world. From the scorching day side, desert-adapted creatures, those species that evolution has already taught to survive extreme heat, would begin their slow journey toward the cooler twilight. Imagine caravans of life moving like invisible rivers across the transformed landscape. Heat-resistant plants sending their seeds on the steady winds. Drought-adapted animals following the scent of cooler air. Hardy microorganisms spreading through dust and water toward more hospitable conditions. From the frozen night side, cold-adapted species would begin their own migration toward warmth. Arctic plants, accustomed to long winters and brief growing seasons, might find the eternal twilight surprisingly welcoming. Cold-weather animals, evolved to conserve heat and survive on limited resources, would slowly make their way toward the boundary where ice meets warmth. But the most fascinating transformations would occur in the species that choose not to migrate. Those that remain in their extreme environments and begin the patient work of adaptation. On the day side, in regions where temperatures soar above 100 degrees Fahrenheit and continue climbing, evolution would favor those organisms that can withstand increasingly intense heat and desiccation. Plants in these scorching regions might evolve new forms of photosynthesis, perhaps developing protective mechanisms that allow them to photosynthesize during slightly cooler periods while shutting down during the hottest times. Some might develop underground root systems that extend for miles, seeking any remaining groundwater, while their surface portions become increasingly minimal, perhaps just small, heavily protected nodes that emerge only when conditions allow. Desert animals already possess remarkable adaptations for extreme heat. Some can survive body temperatures that would be fatal to most mammals. Others have evolved kidneys so efficient they rarely need to drink water, obtaining all their moisture from their food. In our eternal day side, these adaptations would be pushed to their ultimate limits, and perhaps beyond them into entirely new evolutionary territory. In the frozen night side, a different set of evolutionary pressures would shape the survivors. Here, in temperatures that might rival the coldest places on Earth today, but extend across entire continents, life would need to find new ways to generate and conserve heat. Some organisms might evolve more efficient metabolisms, burning their stored energy more completely to generate warmth. Others might develop new forms of biological antifreeze, chemicals that prevent ice crystals from forming in their cells, even at temperatures well below normal freezing points. The darkness itself would become an evolutionary pressure unlike any that life has faced. Plants that survive in the night side would need to abandon photosynthesis entirely, perhaps evolving to draw energy from geothermal sources, chemical reactions in the soil, or even the heat generated by their own decomposition processes. Entire ecosystems might develop around the warm spots created by volcanic activity or geothermal vents, oases of life in an otherwise frozen world. But it's in the twilight zone where the most extraordinary evolutionary experiments would unfold. This region would become a meeting ground for evolutionary strategies that have never before encountered each other. Heat-adapted and cold-adapted species, coming together in a narrow band of moderate temperatures, would create ecosystem interactions that Earth has never witnessed. Imagine forests of twilight-adapted trees, their canopies catching the eternal golden light while their root systems extend, both toward the hot day side, seeking the deep groundwater there, and toward the cold night side, perhaps drawing minerals from the slowly melting permafrost. These trees might develop leaves unlike any we know, optimized not for the changing light conditions of our rotating world, but for the constant, angular sunlight of eternal sunset. The animals of the twilight zone would need to adapt to a world without circadian rhythms, sleep patterns, feeding behaviors, migration routes, all the biological rhythms that have been synchronized to day-night cycles for hundreds of millions of years, would need to find new organizing principles. Some species might develop internal clocks based on temperature fluctuations. Others might synchronize their activities to the movements of the atmospheric rivers flowing between the day and night sides. Predator-prey relationships would evolve in fascinating ways, without the cover of darkness that many hunting strategies depend upon. Nocturnal predators would need to develop new approaches. Similarly, prey species that have relied on the safety of daylight would find themselves in perpetual visibility. New forms of camouflage might evolve. Not the changing patterns that help animals blend into shifting light and shadow, but permanent colorations optimized for the constant golden light of eternal twilight. Bird migration, one of the most remarkable phenomena in our rotating world, would face complete transformation. Many bird species navigate using the sun's position, internal magnetic compasses, and star patterns, all of which would be fundamentally altered in our still world. Some birds might abandon migration entirely, establishing permanent territories in the twilight zone. Others might develop new migration patterns, perhaps following the temperature gradients or the atmospheric rivers that flow between hot and cold regions. Pollination systems, those crucial partnerships between plants and insects that have co-evolved for millions of years, would need to adapt to a world without the daily rhythms that have synchronized flowering and insect activity. Some plants might evolve to bloom continuously in the steady twilight conditions, while others might develop new timing mechanisms based on temperature, humidity, or other environmental cues that remain variable in this strange new world. The human survivors in this twilight realm would face their own adaptation challenges. Circadian rhythms, so fundamental to human health that disrupting them causes serious medical problems, would need to adjust to a world without sunrise or sunset. Communities might develop new daily rhythms based on meals, work cycles, or social activities rather than the natural light cues that have governed human societies throughout history. Agriculture in the twilight zone would require completely new approaches. Crops accustomed to daily light cycles would need to be replaced with varieties that can photosynthesize efficiently in the constant, angled sunlight. Growing seasons, traditionally tied to the annual cycle of lengthening and shortening days, would become meaningless. Instead, farmers might develop new rhythms based on the movement of weather systems through the twilight zone or the seasonal availability of water from the melting and freezing processes occurring at the boundaries with the day and night sides ... Without the visual cues of sunrise and sunset to mark the passage of days, people might develop new ways of measuring and experiencing time. Some communities might create artificial rhythms using bells, ceremonies, or other social markers to replace the natural cycles that have structured human experience. Since our species evolved, the children born in this twilight world would be the first humans in history to grow up without ever seeing a sunrise or sunset, without experiencing the natural rhythm of day and night. That has shaped human consciousness. Human psychology, too, would need to adapt to a world where time itself seems to have since our earliest ancestors. Their relationship with time, with light, with the very concept of change might be fundamentally different from anything in human experience. Yet perhaps most remarkably, in this narrow band of eternal twilight, life would continue its most fundamental work: reproduction, growth, adaptation, and evolution. The great genetic library of Earth, accumulated across billions of years, would continue to be edited and expanded even under these unprecedented conditions. New species would emerge, new partnerships would form, and new solutions to the challenges of existence would be discovered. In the narrow band where eternal day meets endless night, life finds a way. As we emerge from the deep currents of our planet's magnetic heart, we return to the surface of our transformed world to witness perhaps the most remarkable story of all: the quiet persistence of life in conditions that Earth has never before experienced. In the twilight zone, that narrow ring circling our planet where the sun hangs forever on the horizon, evolution begins writing a new chapter in the 4 billion-year story of life on Earth. Picture this realm of eternal golden hour, where the light never changes and shadows never move. Here, neither scorching heat nor bitter cold dominates, but instead a perpetual state exists between the two extremes. The temperature hovers in ranges that, while challenging, remain within the bounds that life has learned to navigate. This narrow band, perhaps only a few hundred miles wide, becomes Earth's final sanctuary, a refuge where the great experiment of terrestrial biology continues under the strangest conditions our planet has ever known. The first migrants to this twilight realm would be the refugees from both sides of our divided world. From the scorching day side, desert-adapted creatures, those species that evolution has already taught to survive extreme heat, would begin their slow journey toward the cooler twilight. Imagine caravans of life moving like invisible rivers across the transformed landscape. Heat-resistant plants sending their seeds on the steady winds. Drought-adapted animals following the scent of cooler air. Hardy microorganisms spreading through dust and water toward more hospitable conditions. From the frozen night side, cold-adapted species would begin their own migration toward warmth. Arctic plants, accustomed to long winters and brief growing seasons, might find the eternal twilight surprisingly welcoming. Cold-weather animals, evolved to conserve heat and survive on limited resources, would slowly make their way toward the boundary where ice meets warmth. But the most fascinating transformations would occur in the species that choose not to migrate, those that remain in their extreme environments and begin the patient work of adaptation. On the day side, In regions where temperatures soar above 100 degrees Fahrenheit and continue climbing, evolution would favor those organisms that can withstand increasingly intense heat. And desiccation. Plants in these scorching regions might evolve new forms of photosynthesis, perhaps developing protective mechanisms that allow them to photosynthesize during slightly cooler periods while shutting down during the hottest times. Some might develop underground root systems that extend for miles, seeking any remaining groundwater, while their surface portions become increasingly minimal, perhaps just small, heavily protected nodes that emerge only when conditions allow desert. Animals already possess remarkable adaptations for extreme heat. Some can survive body temperatures that would be fatal to most mammals. Others have evolved kidneys so efficient they rarely need to drink water, obtaining all their moisture from their food. In our eternal day side, these adaptations would be pushed to their ultimate limits, and perhaps beyond them into entirely new evolutionary territory. In the frozen night side, a different set of evolutionary pressures would shape the survivors. Here, in temperatures that might rival the coldest places on Earth today, but extend across entire continents, life would need to find new ways to generate and conserve heat. Some organisms might evolve more efficient metabolisms, burning their stored energy more completely to generate warmth. Others might develop new forms of biological antifreeze, chemicals that prevent ice crystals from forming in their cells, even at temperatures well below normal freezing points. The darkness itself would become an evolutionary pressure unlike any that life has faced. Plants that survive in the night side would need to abandon photosynthesis entirely, perhaps evolving to draw energy from geothermal sources, chemical reactions in the soil, or even the heat generated by their own decomposition processes. Entire ecosystems might develop around the warm spots created by volcanic activity or geothermal vents, oases of life in an otherwise frozen world. But it's in the twilight zone where the most extraordinary evolutionary experiments would unfold. This region would become a meeting ground for evolutionary strategies that have never before encountered each other. Heat-adapted and cold-adapted species, coming together in a narrow band of moderate temperatures, would create ecosystem interactions that Earth has never witnessed. Imagine forests of twilight-adapted trees, their canopies catching the eternal golden light while their root systems extend, both toward the hot day side, seeking the deep groundwater there, and toward the cold night side, perhaps drawing minerals from the slowly melting permafrost. These trees might develop leaves unlike any we know, optimized not for the changing light conditions of our rotating world, but for the constant, angular sunlight of eternal sunset. The animals of the twilight zone would need to adapt to a world without circadian rhythms, sleep patterns, feeding behaviors, migration routes, all the biological rhythms that have been synchronized to day-night cycles for hundreds of millions of years, would need to find new organizing principles. Some species might develop internal clocks based on temperature fluctuations. Others might synchronize their activities to the movements of the atmospheric rivers, flowing between the day and night sides. Predator-prey relationships would evolve in fascinating ways. without the cover of darkness that many hunting strategies depend upon. Nocturnal predators would need to develop new approaches. Similarly, prey species that have relied on the safety of daylight would find themselves in perpetual visibility. New forms of camouflage might evolve. Not the changing patterns that help animals blend into shifting light and shadow, but permanent colorations optimized for the constant golden light of eternal twilight. Bird migration, one of the most remarkable phenomena in our rotating world, would face complete transformation. Many bird species navigate using the sun's position, internal magnetic compasses, and star patterns, all of which would be fundamentally altered in our still world. Some birds might abandon migration entirely, establishing permanent territories in the twilight zone. Others might develop new migration patterns, perhaps following the temperature gradients or the atmospheric rivers that flow between hot and cold regions. Pollination systems, those crucial partnerships between plants and insects that have co-evolved for millions of years, would need to adapt to a world without the daily rhythms that have synchronized flowering and insect activity. Some plants might evolve to bloom continuously in the steady twilight conditions, while others might develop new timing mechanisms based on temperature, humidity, or other environmental cues that remain variable in this strange new world. The human survivors in this twilight realm would face their own adaptation challenges. Circadian rhythms, so fundamental to human health that disrupting them causes serious medical problems, would need to adjust to a world without sunrise or sunset. Communities might develop new daily rhythms based on meals, work cycles, or social activities rather than the natural light cues that have governed human societies throughout history. Agriculture in the twilight zone would require completely new approaches. Crops accustomed to daily light cycles would need to be replaced with varieties that can photosynthesize efficiently in the constant, angled sunlight. Growing seasons, traditionally tied to the annual cycle of lengthening and shortening days, would become meaningless. Instead, farmers might develop new rhythms based on the movement of weather systems through the twilight zone or the seasonal availability of water from the melting and freezing processes occurring at the boundaries with the day and night sides. Without the visual cues of sunrise and sunset to mark the passage of days, people might develop new ways of measuring and experiencing time. Some communities might create artificial rhythms using bells, ceremonies, or other social markers to replace the natural cycles that have structured human experience. Since our species evolved, the children born in this twilight world would be the first humans in history to grow up without ever seeing a sunrise or sunset, without experiencing the natural rhythm of day and night. That has shaped human consciousness. Human psychology, too, would need to adapt to a world where time itself seems to have since our earliest ancestors. Their relationship with time, with light, with the very concept of change might be fundamentally different from anything in human experience. Yet perhaps most remarkably, in this narrow band of eternal twilight, life would continue its most fundamental work: reproduction, growth, adaptation, and evolution. The great genetic library of Earth, accumulated across billions of years, would continue to be edited and expanded even under these unprecedented conditions. New species would emerge, new partnerships would form, and new solutions to the challenges of existence would be discovered. Across millions of years, our still world begins its most profound transformation yet. As we reach the final chapter of our journey through this imagined world, we must lift our perspective beyond the immediate dramas of atmospheric chaos, ocean redistribution, and biological adaptation. We must think in the deep time of geology itself, millions, hundreds of millions, even billions of years into the future, to witness the ultimate transformation that awaits our motionless planet. Picture yourself as a patient observer, watching Earth from space across geological epochs, witnessing changes so slow and fundamental that they reshape not just the surface of our world, but its very form. In our rotating Earth, the planet bulges slightly at the equator due to centrifugal force, a subtle but measurable distortion that makes our world not quite a perfect sphere, but rather an oblate spheroid, wider at the middle than at the poles. Without rotation, this ancient bulge begins a transformation that will unfold across deep time, gravity. That most patient and persistent of forces begins the slow work of reshaping our planet into a perfect sphere. This isn't a process that could be observed within human lifetimes, or even within the span of entire civilizations, but across the millions of centuries that geology measures. Earth would gradually lose its equatorial bulge and become truly round for the first time since it began spinning billions of years ago. Imagine the slow, inexorable flow of rock and molten material as our planet adjusts to its new form. The excess material that has collected around the equator for 4.5 billion years would begin to redistribute, flowing gradually toward the poles under gravity's patient influence. Mountain ranges might slowly sink as the land beneath them adjusts to new stress patterns. Ocean basins might deepen or shallow as the planetary surface finds its new equilibrium. This transformation would occur through processes we can barely imagine. The solid rock of Earth's crust and mantle, which seems permanent and unchanging on human timescales, flows like thick honey when measured across geological time. Continents drift, mountains rise and fall, ocean floors spread and sink, all as part of the planet's constant internal motion. In our still world, these same forces would slowly reshape Earth's fundamental geometry, but our planet would not be alone in driving these changes. The Moon, our faithful companion for over 4 billion years, would continue its gravitational dance with Earth even in our world of stillness. The tides, those rhythmic pulses of oceanic rise and fall that have shaped coastlines and influenced life since the first seas formed, would take on entirely new patterns in our transformed world. Without Earth's rotation, tidal forces would work differently. Instead of the familiar cycle of high and low tides that circle our planet every day, following the Moon's position in the sky, our still Earth would experience a different kind of tidal pattern. The Moon's gravity would still pull on our oceans and even on the solid rock of our planet, but without rotation to carry different parts of Earth through the tidal bulge. The pattern would become more like a permanent distortion, with one side of our planet always experiencing the moon's strongest pull. Picture the strange new tides of our still world, permanent high tide regions that face the moon, permanent low tide zones on the opposite side of the planet, and gradual transitions between them. These wouldn't be tides that rise and fall with predictable rhythms, but fixed tidal landscapes that would become as permanent as mountain ranges, shaping the geography of our transformed Earth across geological time. The Sun, too, would continue to exert its gravitational influence, creating its own tidal effects on our motionless world. The interplay between solar and lunar tides, no longer modulated by Earth's rotation, would create complex patterns of gravitational stress that would slowly sculpt our planet's surface. Across millions of years as we peer deeper into this geological future, we encounter perhaps the most profound change of all: the gradual slowing and eventual cessation of plate tectonics, the great engine of geological change that has been reshaping Earth's surface for billions of years. Plate tectonics depends partially on convection currents in the mantle that are influenced by Earth's rotation. The Coriolis effect, which vanished from our atmosphere and oceans when rotation stopped, also plays a subtle but important role in the patterns of rock flow deep within our planet. Without these rotational influences, the great conveyor belt of plate tectonics might gradually slow and simplify the mid-Atlantic ridge, where new ocean floor is constantly created as North America and Europe drift apart, might eventually quiet the ring of fire round the Pacific, driven by subduction zones where ocean plates dive beneath continental masses, might gradually weaken as the forces driving plate motion change. This doesn't mean geological activity would cease entirely. Earth's interior would still be heated by radioactive decay, and convection currents would still flow through the mantle. But the complex, dynamic patterns of plate movement that have created and destroyed ocean basins, built and eroded mountain ranges, and recycled Earth's crust for billions of years would gradually simplify into more basic convection patterns. Volcanic activity would continue, but perhaps in different patterns. Some volcanic regions might become more active as simplified mantle flow concentrates heat and molten rock in new locations. Others might gradually quiet as the forces that once fed them change direction. The great volcanic chains created by plates moving over stationary hot spots in the mantle, like the Hawaiian Islands or Yellowstone, would cease to form new volcanoes, though existing volcanic features might remain active for millions of years. As plate tectonics slows, mountain building would also change. The great ranges created by continental collision, the Himalayas, the Alps, the Appalachians, would gradually erode without new tectonic forces to maintain their height. But in a world without rotation, new mountains might form in different ways, perhaps through the slow buckling of Earth's crust as our planet adjusts to its changing shape, or through volcanic activity concentrated by the simplified convection patterns in the mantle. The climate of this far future Earth would stabilize into patterns unlike anything our planet has experienced, with the ocean currents, atmospheric circulation, and heat distribution all fundamentally altered by the absence of rotation. Ice ages and warm periods might follow entirely different cycles, if they occur at all, the climate might become remarkably stable, locked into the pattern of scorching day side, frozen night side, and temperate twilight zone, with only gradual changes as the planet's shape and internal heat flow slowly evolve. In this deep future, the very concept of continents might lose meaning as the land masses revealed by ocean redistribution are slowly reshaped by geological forces operating without rotational influences. The Great Ring continent that emerged around the equator, as ocean levels dropped, might gradually break apart as the underlying geology adjusts to new stress patterns. Or it might remain as a permanent feature of our spherical world, the polar oceans, those deep seas that formed as water migrated away from the equator, would become the dominant features of our planet's geography. These might become the deepest bodies of water Earth has ever known, as material from the shrinking equatorial region slowly flows toward the poles under gravity's influence. In the eternal darkness of the night side, these polar seas would freeze to depths that dwarf any ice formation in Earth's history. Yet even in this transformed world operating on geological times scales, life would continue its patient work of adaptation and evolution. Species that survived the transition to our still world would continue to evolve, perhaps developing forms and capabilities that Earth's rotating biology never imagined. In the stable twilight zone, evolution might proceed along entirely new pathways, no longer influenced by the daily and seasonal cycles that have shaped life for billions of years. Some forms of life might eventually recolonize the extreme regions, as evolution develops new solutions to the challenges of perpetual heat and cold. Deep-sea life in the polar oceans might thrive in the stable conditions of eternal darkness. Geothermal organisms might spread through the volcanic regions, creating ecosystems based entirely on Earth's internal heat rather than solar energy. Some forms of life might eventually recolonize the extreme regions, as evolution develops new solutions to the challenges of perpetual heat and cold. Deep-sea life in the polar oceans might thrive in the stable conditions of eternal darkness. Geothermal organisms might spread through the volcanic regions, creating ecosystems based entirely on Earth's internal heat rather than solar energy. Across these vast timescales, even the sun itself would be changing. Our star, like all stars, gradually brightens as it ages, increasing its energy output by about 10% every billion years. In our far future still Earth, this slowly increasing solar radiation would intensify the temperature extremes, making the day side even hotter while potentially providing just enough additional energy to prevent the night side from freezing completely solid. The moon, too, would continue its slow retreat from Earth, moving away from our planet by about 1.5 inches each year, as tidal forces gradually transfer energy from Earth's rotation to the moon's orbit. But in our still world, this process would change dramatically. Without Earth's rotation to provide the energy for this transfer, the moon's orbit might stabilize at its current distance, or it might even begin to slowly spiral inward as other gravitational effects take precedence. As we imagine this ultimate future, Earth is a perfect sphere, geologically quiet, climatically stable, with life persisting in forms we can barely imagine. we encounter one of the most profound questions in planetary science. Is this the natural fate of all rocky planets? Venus, with its incredibly slow rotation, already resembles our imagined still world in some ways. Mars, smaller and cooler, shows us what happens when geological activity slows and magnetic fields fade. Perhaps our thought experiment has taken us not just to an imagined future, but to a glimpse of how planetary evolution might unfold across cosmic time. Rocky planets might begin their lives spinning rapidly, with dynamic geology and protective magnetic fields, but gradually slow and stabilize into more spherical, geologically quiet worlds as they age. Earth's current state, actively rotating, geologically dynamic, magnetically protected, might be just one phase in a much longer planetary life cycle. In this vision of deep time, our still Earth becomes not just a thought experiment about catastrophe, but a meditation on the ultimate fate of worlds. It reminds us that even the most fundamental features of our planet, its rotation, its magnetic field, its dynamic geology, are not permanent fixtures, but temporary states in the long evolution of a rocky world orbiting a star dot as we drift back from this imagined future. Across the millions of years and vast transformations of our thought experiment, we return to our spinning world with new appreciation for its dynamic complexity. Every sunrise and sunset, every changing season, every flowing river and shifting cloud becomes a reminder of the intricate dance of forces that makes our current Earth possible. The gentle spin that creates our days and nights, drives our weather, generates our magnetic field, and shapes our geology is revealed not as a simple fact of existence, but as an extraordinary cosmic gift, a temporary state of grace in the long story of planetary evolution. Our Earth, in its current form, is not just our home, but a rare and precious moment in the deep time of cosmic history. And perhaps that is the most profound lesson of our journey through this still world, that the familiar Earth we know, with all its motion and change and dynamic beauty, deserves our wonder not just for what it is, but for how remarkable it is that such a world exists at all in the vast, patient cosmos. A gentle return to our spinning world as you drift back to wakefulness from this journey through an imagined Earth. Let yourself feel the gentle motion of our actual world, the subtle sensation of rotation that you carry with you always, even though you rarely notice it. Right now, as you rest, you are traveling through space at over 1,000 miles per hour. Part of a cosmic dance that has continued unbroken for billions of years. The next time you watch a sunrise or sunset, remember that you are not seeing the sun move across the sky, but feeling Earth's faithful rotation carrying you through the cosmic light. The next time you feel a breeze or watch clouds drift overhead, remember the Coriolis forces and circulation patterns that are possible only because our world spins. The next time you check your phone's GPS or look up at a satellite passing overhead, remember the intricate technological dance that depends on our planet's predictable rotation. Every day and night, every season, every flowing river, and shifting magnetic field is a gift from the rotation that began when our world was young and has continued, with only the slightest variations, through the entire history of life on Earth. We live in a remarkable moment. In cosmic time, on a planet that is young enough to be geologically active, large enough to maintain its rotation, and perfectly positioned to sustain the complex dance of forces that makes life possible. Sweet dreams of spinning worlds and cosmic motion. And may you wake tomorrow with wonder at the gentle miracle of Earth's faithful dance through space and time. If this journey through our still world has filled you with wonder about the cosmos we call home, gently tap that subscribe button and ring the bell for more explorations into the beautiful mysteries of space and time. Until our next cosmic adventure, may your dreams be filled with the gentle spin of our remarkable planet, carrying you safely through the night toward another dawn in our dancing world.